So can I start?
Yeah, good morning, everyone. Good afternoon in other parts of Japan, and good morning in India, and to the chapter members. Welcome to the talk of Dr. Haruhiko Okumura. He's working in Toshiba R&D Corporation as a senior scientist. He's an IEEE fellow, and he's a very well-renowned person in the area of display technologies. And he's currently an IEEE distinguished lecturer of IEEE Consumer Electronics Society. So I would like to welcome Dr. Okumura. So he's going to give us a talk about next generation display technologies. So Dr. Okumura, the floor is yours. You may please start your talk. Thank you.
Thank you. Thank you for your introduction. My name is Haruhiko Okumura. Thank you for joining my lecture. And today, good afternoon, ladies and gentlemen. Well, today I'd like to talk about next generation innovative display technologies. Yeah, in the last lecture, I talked about how to make innovation lesson learned by several display innovations based on my experience. Yeah, today, so in the last lecture, the very past innovative technology I introduced. So today I would like to introduce some innovative future display technologies. Yeah, this photograph shows some of our expecting next generation display, wearable display or pen type rollable display. So this is the abstract of my lecture. And I already introduced myself in the last lecture, but quickly introduce myself. Yes, I'm a display researcher and graduate from Waseda University. And I have been engaged in working on development image processing for image sensor, image compression, and flat panel displays. So my expertise is widely extending from camera technology to display and evaluation that generate innovative based on yes, the very wide field of expertise, innovate some new idea. Please remember it, yes. This overdrive LCD or 3D IITV monocular head-up display is generated. Those kind of innovative concept was generated by the very wide field of technologies. So at first, I would like, this is the outline of my presentation. Firstly, history of past innovation technologies for displays. I quickly review the past innovative display technologies. Next, I would like to introduce innovative near future display technologies exhibited in Consumer Electronics Show this year. After that, I would like to explain technically about display, future display technology in more detail. The device as a new device, flexible display technology and the micro LED technology, and as a new novel innovative system technology, AR VR technology was introduced. And I'd like to summarize my talk. At first, I already introduced in the last lesson, the old common sense leads, what is innovation? The old common sense leads a continuous advancement of performance. However, after innovation, new common sense leads the discontinuous extraordinary fast advancement of performance. A key factor for success is inventing the fusion of new hardware and software in different technical fields. These are TOSHIBA innovative products. One of them is LCD TV with overdrive. I introduced in the last lesson, and the 3D II TV released in 2011. And these are innovative display technologies, past innovative display technologies selected by the SID in 2012. One of them is overdrive technology and low temperature polysilicon technologies developed by TOSHIBA. And this figure shows the number of innovative technologies by companies. Sharp is most Sharp is first, and TOSHIBA has two technologies, innovative technologies. And key point for success to invent innovative concept is innovative concept making stage. At the innovative concept stage, simple idea invented by the integration of a wide field of technologies I experienced. So that breaking common sense. And second is taking the first step with strong encourage against common sense. And thirdly, at the development product stage, little and often feel the path is most important. So next, I would like to introduce innovative future displays exhibited in Consumer Electronics Show. Yes. Please look at this photograph. Each pixel, this is a 3D floating display consisted of dynamically flying more than 250 drones. This means one pixel is one drone. So display shape can be easily changed depending on the location of the drone. Very extraordinary innovative display technologies. And then I would like to introduce some innovative display technologies exhibited CES 2020. Very big consumer electronics show, as you know. And this is the most impressive display technology. And yeah, this video shows also drone display. Maybe 400, more than 400 drone make a new 3D image in the air. Yeah. The fireworks also displayed by drone. And as a new type of display, micro LED was exhibited. This is a micro LED. Very wide dynamic range, like CRT. Yeah. The sunshine can be displayed on the micro LED. I will explain the technology in more detail afterward. And next one is flexible OLED display, developed by LG. This is a curved type, a lot of curved type display combined. The very big display, very big curved display can be achieved. I'm sorry, the communication capacity is not enough. So motion is not smoothly moved. Not good motion image quality, sorry. But very immersive display you can experience. This is sea, as if you are in the sea. You are in the sea. Okay. Next one is rollable bendable display. Rollable display. The display can be put in this area. Can be installed. Yeah. Roll display is located in this area and go up to, yeah, the flat panel display appeared. Yeah. And disappeared. Yeah, very impressive display technology. Next one is also rollable flexible display, so I skip it. And next one is 8K OLED, a very high resolution display. This photograph also 8K OLED. And micro LED also very big wall type micro LED also has been developed. Yeah, very more than 300-inch display can be realized by using micro LED technology. Samsung called it wall display. The wall, yeah. Okay, next one is also wall display. And next one is transparent display. Transparency, please look at this video. This, he stand back of the transparent display. So you can see him through the transparent display. Next one is AR, MR, VR, ultra big display. Yeah, the title is a virtual image, and the other image is real image. So virtual image overlapped on the real image, and very big size and immersive display. AR, VR display can be, you can see the very big size AR, VR display. And next one is VR car. Yeah, they are wearing the VR headset, and real car is moving. So they can experience as if they ride the real car. And this is haptic VR. Yeah, haptic technology also had been advanced and improved. So we can use haptic technology for VR. And this is a VR glass. Yeah, a little bit strange, but very wide field of view. More than 90-degree field of view can be achieved. And very high resolution, 2,245 ppi. A normal smartphone has 300, from 300 to 400. So 6 times or 8 times, 7 times high resolution than the present the product. And this is a very unique display technology. Turning LED display. The line LED, turning the line LED, we can see the 3D image. This also turning LED. Yeah, turning like propeller. Yeah, and we can see the virtual image in the air. And light field 3D display also introduced. this is a light field display, very small size, but a very immersive display. Yeah. And so next, I would like to talk about next generation display technology in more detail. Flexible display, micro LED, and AR VR display technologies. This figure shows next generation display technologies plotted at two axes of resolution and size. Horizontal axis shows the size, vertical axis shows the resolution. As next generation innovative displays, we will focus on 4 displays: immersive display, 3D display, e-paper, paper-like display, and AR/VR display. For immersive displays, larger size than 100-inch with flexible will be required. For 3D, extraordinarily higher resolution than 8K to emphasize depth display capability will be required. For e-paper, flexible and high reflective low power display will be required. For AR/VR display, higher density of smaller size than 1 inch and higher resolution than high definition will be required. Very high density, small size display is required to reduce the size. Okay, so for focusing on 4 innovative display, I would like to explain. At first, immersive display. At the first TV era, before LCD TV, small size CRT TV has been popular. As I mentioned in the last lecture, overdrive technology opened new large size and panel TV market. I'm sorry, new large size flat panel TV market. That is second TV era. So what is next TV era? I think immersive TV era is coming as the third TV era. It will be wide field of view, no flat, and frameless display that can disappear the border between virtual and real space. That means we can feel the virtual image space in our brain like this. Our final target is invent an innovative display to let us feel like as if we exist in virtual image space, like this. Nobody knows the solution of this question even now. So in 2004, to experience feeling the image space display, we developed extraordinarily wide field of view of more than 160-degree dome-type display simulator we developed. So, and with head tracking technology, you can see 360-degree motion image space you can experience. I was completely realized feeling the image space by using this dome display, and I was so moved that I couldn't put it into words. This figure shows the results of subjective variations by using immersive dome-type simulator. It indicated that not cylinder, but a dome-shaped screen is the best for enhancing hyperreality and immersion. So we found flexibility is a must to achieve immersive display. This is to the key technology. So key technology for immersive display is flexible, rollable display like that. As I already introduced. So I would like to skip it. And next, I'd like to explain about the method, how to make flexible display. The display panel consists of display mode, TFT driving, and substrate. So in the display mode, LCD, organic ELD, EL or LED, as a TFT, amorphous silicon, polysilicon oxide TFT, or crystal silicon. As a substrate, glass or plastic or metal. So for flexible type display, the best solution is plastic substrate and polysilicon or oxide TFT and organic EL. So, but to make organic polysilicon or oxide TFT, a higher temperature, for 400 or 600 degrees Celsius is required. So, but so lower temperature manufacturing method is required to realize a flexible display. This is a typical current control driving circuit for active matrix OLED. OLED needs high driving ability with more than 50 square centimeter per VS mobility and from 5 to 10 volts driving voltage. Therefore, polysilicon or exo TFT is required. However, those drive devices need high temperature manufacturing process. There are mainly two methods to make TFT driver on flexible substrate with low temperature. One is direct manufacturing method. The other is indirect manufacturing method. Yeah, the dynamic manufacturing method is directly manufactured on the plastics film, and indirect manufacturing is at first high temperature, by using high temperature manufacturing process, the TFT is made on the glass substrate, and after that transfer it to plastic substrate. And this figure shows the principle of TFT-driven active matrix OLED. Basically, light emission is caused by recombination of electrons. In addition, higher luminous efficiency is also required to reduce power and temperature for flexible display. Luminous efficiency is improved by mainly two factors. One is internal quantum efficiency, and the other is light extraction efficiency. In case of normal structure of OLED device, most emitted light based on recombination can't go out due to confined structure. So, okay, structure. Luminous efficiency is expressed as the equation that is light extraction multiplied by internal quantum efficiency. As I mentioned in the last slide, emitted light cannot go out due to confined structure like this. So recycling technology is required. Another method for improving light extraction efficiency is top emission structure to increase aperture ratio of the pixel. In the conventional structure of bottom emission as shown at upper figure, emissive light cannot go out in the TFT-driven region. On the other hand, in the top emission type, TFT driver is set under emission layer, and emission does not go through the driver area, so that 100% emission can be achieved. So let's move on to the next part. MRI HUD. The dome type display can be applied to MR head-up display. This system is mainly one of the application is medical use MRI HUD. So I would like to explain the MRI HUD. This system is mainly composed of 3 components: a projector located outside the magnetic field, and dome type display. As you can see, dome type display is set on the head, over the head. And you can see the very massive display during the MRI. So so patient won't have to worry about the limited narrow space. This is a dome type MRI system. Very wide field of view over 140 degrees has been achieved. This figure shows the dome type MRI HUD. This is the dome shape. Can you see the demonstration?
Yeah, it is going on. The video is going on, but it's a bit slow. Dr. Okumura?
Yes.
I have a question.
Yes.
How do you achieve high dynamic range in your display technologies?
High dynamic range, where by LED has very high dynamic range, where to achieve high dynamic range display, the black level is most important.
Okay.
Yes. So by attaching the special optical system on the display,
Right.
and to reduce the black level.
Okay.
Yeah,
So,
the black, to reduce the black level, the reflection, the outside light, to remove the outside light is
okay.
important. The outside light goes through the display and reflect it to the observer, reflect to the light, the observer.
Right. So
So
you
to
would need 10-bit LCD, 10-bit LCD
yes, 10-bit LCD, the
and
one
HDMI
is
HDMI support, HDMI version 2.0.
not just to explain the display hardware technology, so not system technology. Yeah. So yeah, high dynamic range signal can be displayed the on the high dynamic range display. Yeah, but the basically speaking, if the display has does not have high dynamic range ability,
Right.
if the the original image has high dynamic range,
Right.
we cannot see the high dynamic range image.
On the TV
So
products, for
this
example. Yeah.
display device need high dynamic range performance.
Right.
So to achieve high dynamic range device, most important point is reduce the black level, and another point is the higher bright level, higher bright level.
Right.
Reduce the black level and higher bright level. So
Did any
yes,
Samsung
yes,
product upgrade to HDR recently? Did any Samsung product
yes,
upgrade to HDR like Samsung TVs and stuff? From SDR
yes.
to HDR, did
I
they
mean,
upgrade?
maybe yes, the Samsung display can reproduce high dynamic range image.
Mhm. Okay.
Yes.
Okay. Thank you, Dr.
Okay.
You may continue.
Okay.
Thank you.
So next. Yeah. Okay. So next one is flexible. Next one is e-paper. E-paper. Okay. At first, I'd like to briefly explain about the principle of reflective type display. E-paper is reflective type display, so the principle of reflective display compared with transparent LCD. Okay. Sorry. The left side figure shows the reflective type display, and right side figure shows transparent display. A transparent display has needs a backlight unit, but a reflective type LCD does not need a backlight. Only outside illumination is required. So very low power can be achieved. And not only is the principle of the reflective type display is completely different with transparent type display, but also image quality evaluation and target specification also completely different. So I'd like to tell you about image quality evaluation method for reflective type display. These are evaluation condition. And this figure shows the result of the evaluation. So, for example, for newspaper, more than 50% visual reflectivity and contrast ratio is 5. So the score, subjective score is about around between 3 to 4. Yeah. So higher reflectivity and higher contrast ratio is required to achieve higher reflective type, higher image quality. So I set score 4, more than score 4. Target specification is score 4. The reflectivity is more than 60% and the contrast ratio is more than 5, according to the result. To achieve the performance, three-layer guest host type is required, as shown in this figure. Yeah, non-color filter type. Yeah, color filter. In the case of color filter type, very reflectivity is less than 30%. So more than 60%, non-color filter type is required. So we select three-layer guest host type, reflective type display. This is a conventional color filter type display. And this is a three-layer guest host type display. No color filter, so we can achieve higher reflectivity. This is this photograph shows our developed tri-layer guest host display. And let's move on to the next part, AR/VR display. In AR display, there is 4 types. One is head mount type display. Second is handheld type. That is mobile type display. Third is desktop type, including head-up display for automobile. Last one is projection type display. This figure shows fundamental see-through optical system for AR head-mount type display and head-up type display. This is a head-mount display history from 1968 to the present. Yeah, in 1968, the head-mount display were invented, and the reducing the size recently the glass type display can be developed. So this figure shows the most difficult issue to be solved for AR head-mount display and head-up display system. In the wide viewing capability point of view, in the conventional AR optical units, as shown in this figure, the wider viewing caused larger volume size of optical unit. Therefore, a trade-off between compactness, size, and field of view must be solved to achieve wide field of view. Yeah, very optical system become very big to achieve wide field of view. So we developed small size to reduce the size. Micro mirror array display were developed. This is a principle of the display. A micro mirror array directly exposed in the air. The where sight through the multiple mirror array is distorted because of the infraction in the prism. To prevent this problem, we use the material use the same reflective index in both the MMA basement and the cover plate. The main point is very thin optical lens thickness, only 2.7 meter by using our developed MMA optical system. MMA concept also can be applied to head-up display system. It is a transparent solid resin sheet or plate containing a Fresnel half mirror surface inside. It acts as a transparent plate for transmitted light, but it acts like a concave Fresnel mirror for reflective light. So it's very useful for AR displays that have to see the background or scenery such as head-up display. Yeah, reflective light can be enlarged, but the see-through image, no distortion, no optical power in our system, in this system. Like that. Reflective light optical power has optical power. Transparent emitted light, no optical power. This figure shows the future of the head-up display. This blue sign navigate you to your destination. The color depends on the traffic light. Color can be changed. Yes. And other application, other application, the HUD technology can be also applied to the medical use, as shown in this figure. Doctor can see the medical information overlapped on the real patient. This is a head-up display for medical use. but this is a female logic surgery, so I cannot explain in more detail. And finally, I'd like to talk about new display device technology, micro LED. Conventional LED has larger than 200 micropixel size. On the other hand, for mini and micro LED, pixel size is reduced to less than 200 micron or 50 to 200 micron for mini and less than 50 micron for micro LED. The key technology for mini and micro LED is assembly technologies. Not device, but assembly technology, because whether display size is larger or not, driving circuit and lighting device are separately manufactured on different backplanes. And after that, combined together by using assembly technologies, as shown in this figure. This figure shows the illustration for active matrix micro LED developed in 2018. TFT drive circuit and lighting device are separately manufactured on different backplanes. After that, 1024 micro LEDs are integrated and bonded on top of TFT backplane. Full color micro LED are mainly classified into three methods. First is transfer of RGB microchips to driving substrate. Second is monolithic gross integration of RGB micro LEDs. Third is blue UV micro LED with accumulated color conversion layer on. Sony has developed very large size tiled module type micro LED of 9.75 square meter by 2.74 meter with 8K 2K resolution in 2019 for the first time. Very large size display was developed. And Samsung also developed wall type micro LED, as I mentioned before. 75-inch 4K micro LED in 2019. 19. Chip size is 30 micron. Yeah, very high resolution display can be has been achieved. This figure shows one example. One example for micro LED already developed by Ostendo in 2015, 5 years ago. Ultra high brightness of more than 20,000 candela per square meter with 5 to 20 has been achieved. Yeah. And the major challenge for micro LED are mainly classified into 6 items. First and second are main issue, mass transfer method and defect management to reduce cost, as shown in next slide. Third is color formation, related to the method how to reproduce full colors. Fourth is increasing light extraction efficiency. Fifth is pixel driving, and finally the LED epitaxial chips. Even if micro LED process yield is 99.99%, for 4K display, 2,488 pixel defect will be generated. Very large number of defects generate. So reducing the defect is the most important and difficult problem. It will take more than 2 hours to repair them. That increase cost. This figure shows the comparison between micro and mini LED and other displays. Micro LED has the highest peak luminance and lowest power consumption, but cost is expected to be one order higher due to complex assembly process. Cost is the biggest problem for micro LED at present. So this is a summary of my lecture. Those technologies will take us toward future innovative floating display era. So what would you like to take as next lecture? As reference, I'd like to have your comments. Vision science, illusion or human perception mechanism, or image recognition technologies, high-speed and high-accurate image processing, or AR VR system technologies, or 3D technologies. Please, okay, please vote one of them. So my personal next challenge is playing violin now. So just challenge my the biggest challenge now. Thank you for your kind attention. See you next lecture.
Okay, thank you. Thank you, Dr. Okumura. It was very informative, and thank you for putting in your tremendous efforts in giving us a wonderful talk. We really appreciate it. I have received a few comments from the chapter members in my chat box. So I would like you to please answer some questions that
Yes.
the chapter members have asked me. One of the questions is, on what factors would the evolution of TV depend upon?
Could you repeat?
On what factors does the evolution of TV systems depend upon?
Evolution. What's it? Depend on. Well, right. For example, micro. The now LCD is. I'm sorry. Now the LCD market is biggest market, but to replace the LCD, the micro LED technology is most promising technology. So to develop the to improve the micro LED technology, the cost program is most difficult to be achieved.
Right.
So device point of view, to reduce the cost, how to reduce the defect is key technology, I think. And the system point of view, Well, I think the AR/VR technology is promising in the future, but key application we cannot have the key application for AR/VR technology. So I think key application technology for AR/VR application technology is most important, I think,
Okay.
to make innovation.
Okay. Next question I have.
Yeah. So yes, you should you try to find a new application for AR/VR.
Right. Right. Okay. Thank you.
To
The
make
next
innovation.
question I have is what is the difference between high definition and standard dynamic range?
High definition. High definition means high resolution. High density. Yeah. Could you the
Yeah.
difference
The
between high
difference between
density and high resolution?
high definition and
Dynamic range.
standard dynamic range.
Dynamic range. Dynamic range is extending the dynamic range. Dynamic range means difference between black level and increase the contrast ratio. So that decrease the black level and increase the bright level. Yes, decreasing the black level, increasing bright and increasing bright level make the dynamic can achieve the high dynamic range. And the resolution, density or resolution is determined by the pixel number.
Mm-hmm. Right.
Higher pixel number, high resolution, high density.
Right.
Is it?
Yeah, yeah, that's it.
Is
Yeah, it answered the question. It answered the question.
Can I? Is
Yeah.
it correct answer?
Yes. Okay. One last question I have from the chapter members. Any specific hardware that is used in the display technologies or enhancing performance?
Could you speak more loudly?
Yeah.
I cannot
The
hear your
question
voice.
is there any advanced hardware that is used for display technologies for enhancing performance?
Performance. Yeah, for one is high immersive to increase immersion and the depth capability, 3D capability are the for next generation display, the what shall I say, the 3D capability, 3D display capability is important. So 2D image is very, we can achieve that very high quality 2D image, but not 3D image. So depth capability is most important. Increasing the depth capability is important. So in our display can emphasize the depth capability. Yeah. So depth capability. So and also many company focused on the development of improving the depth capability.
Okay. Any specific hardware system that is used?
Specific hardware. Well, normal display performance we use. In the dome type display, for the dome type display, just normal projection display we use.
Okay.
We use, but for transparency display, a new type of display is required. Usually not transparent, so very special display is required. So it depends on the application. For flexible type display, low temperature for as a specification, flexibility performance is required.
Okay.
Yeah. So, but for dome type display, no special specification is not required. Is required. Just a normal display, but systematically completely different system.
Right.
For example, okay, I understand the in a dome type display, the optical system is very special. Wide, what shall I say? Special fisheye lens was used. So with no distortion, smaller distortion.
Okay.
For the peripheral image. Yeah, very wide field of more than 160 to achieve more than 160 degree peripheral image tend to be distorted. But by using very high quality fisheye lens, to developing the fisheye lens, we can achieve the clear image even at the peripheral region. Is it correct answer?
I got your point. What you're saying?
Yeah, it depends on the application, I think.
Right.
Yeah.
Right. Okay. Thank you, Dr. Okumura. It was again wonderful to have your informative talk. I'm sure the chapter members and the other people taking part in today's lecture may have benefited slightly and learned a little bit about it. So I would again like to thank you on behalf of all the members, and thank you for spending your valuable time. Okay, so we'll see you again in the next lecture. Thank you so much.
Yeah, thank you very much for your hospitality. Thank you.